Good morning, fifth grade. Today we're going to be learning about Module 3, Lesson 6, and we are going to continue with subtracting fractions. Just the only difference with today's lesson compared to last week's lessons for subtracting is that I'm going to be subtracting fractions that are greater than 1. And usually my answers are going to end up being less than 1, but that's why we kind of learned about different fractions that could either be greater than 1, like 1 and 1/3 is greater than 1. 5/6 is less than 1, and 6/6 would be exactly 1. So we're going to be practicing remembering like what different types of fractions there are, and then we're going to start working on models for them. So today's lesson is going to be a little bit different. We're going to be doing a lot of different steps today, but it's very important that you follow along with me and doing every single step that I do in this video, because you're going to be doing a lot of different things compared to like the old models that you used to do. For example, what I'm going to do when I go to start this problem, normally I would draw my two boxes to show the first fraction, and then I would draw a box to show my second fraction, cut them up so that they have common denominators, and then subtract or add or whatever I have to do. But for this lesson, I am not going to be drawing a box for an area model for this fraction anymore, my second fraction. I'm only drawing an area model for my first fraction, which in this case is 1 1/3. I'm still going to be drawing two boxes though, and that's where it might get a little bit confusing. So I still have two boxes because this is 1 1/3. So that means that I'm going to have one box that will show me one whole, and then I'll have another box to show 1/3. What I basically did is I basically just kind of sliced this down the middle, and I took out the one whole to show that right here. I took out the fraction 1/3, and I'm going to show it right there. But I'm not going to draw a model for a half. So what I now need to do is I need to show you what 1/3 would look like. So I need to cut up this model. So I'm going to cut it into 3 pieces because my denominator is 3. So I need 1, 2, 3 pieces. And then I shade in one of these pieces. So I'll go ahead and shade this in right here. And because this one whole is part of my fraction as well, I will also go ahead and shade in this box. Like I said in previous lessons, I don't need your shading in to be perfect. As long as you shade in just enough to cover most of the box, that works. Now, this is where it might get a little bit confusing, so make sure you're following along with me. Even though I'm not drawing my half, I still need to think about it when I am subtracting my fractions. And I still need to create that common denominator. So in order to do that, I need to cut both of my boxes right here, my whole and my third, in half. And I will still always do that by cutting it horizontally, so straight across. So I cut this box in half, and now I'll cut this one in half. Now I'm not done yet, so I cut both of my models in half because this second fraction told me that I need to do that. But my models still do not totally match because remember, I had to cut this one into thirds at first. So I'm going to cut this one into thirds as well. So just to backtrack real fast, I drew 2 boxes to show 1 1/3. So I have my 1 and my 1/3. I cut this model into thirds because that is the denominator, and then I shaded in 1 to show 1/3. I then cut both of my models in half because that is what I'm subtracting by, and I need those equivalent fractions. Not equivalent fractions, common denominators. So I cut both of my boxes in half. Now, in order to continue subtracting, I still needed both of these cut into thirds. So I cut these down into thirds, and now I have 2 models that look just the same. The only difference is the amount that is shaded in. Now, this is another part that might be a little bit hard to understand, but what I'm going to do is I need to now create my equivalent fraction for 1 1/3. Now, when you're creating this equivalent fraction for 1 1/3, what you have to think about is that 1 1/3 is greater than 1. So when I create an equivalent fraction, it might look a little bit different or be an improper fraction because I'm creating an equivalent fraction that is greater than 1. So it's not going to be 1/2 or 5/6. It might be 8/6 or 7/6 or something like that. So let's see what this one is going to be. In order to create my equivalent fraction, what I have to do is I have to count up all of my shaded in boxes. So I have 1, 2, 3, 4, 5, 6, 7, 8. You have to count up all of the boxes that are shaded in. So I'm going to write 8 in my numerator. And then what I'm going to do is just out of my whole, I'm going to count the total boxes just from the whole. So I have 1, 2, 3, 4, 5, 6. So my new equivalent fraction is 8/6. So 1 1/3 and 8/6 are the same thing. It's just a different way of showing them. And I know that 8/6 is greater than 1 because 8/6 is greater than 1 because 6/6 would be a whole. So 8/6 would be more than that. And now I need to subtract. So if I need to subtract, there's going to be 2 different ways that I could show you this. So I'm going to show you what numerically it would look like, and then what it would look like in picture form. So I'm going to start with the picture form of it. So imagine if I were just to subtract 1/2 off of this box. So if I were to think about a box that was cut in half, that would be that 1/2 right there. So what I'm going to do is I'm going to imagine with my different color marker that I am cutting off 1/2 of it. So I'm going to cross out 1/2 of the boxes out of my whole model right here. So I know that I cut it in half earlier. So I'm basically going to cut off 1/2. So what I did is I had 8/6. And now I subtracted 1/2 of those. So I cut off 1, 2, 3 boxes out of 6 boxes. So 8 minus 3 is 5, 6. And I can check my answer to see if it's correct because then I can count the total amount of boxes that are left over. So I have 1, 2, 3, the other model, 4, 5 out of a total of 6. So I know that was a little bit weird. It's very different from what we've been doing, but just continue working along with me. So let's take a look at how it would look like numerically. So if I have 8/6 minus 1/2, what I need to do now is I need to have common denominators between these two. So what I'm going to think about is I need to multiply 2 by something so that it can be 6. So I know that 2 times 3 would be 6. So I'm going to multiply this by 3. So 2 times 3 is 6. And then whatever I do to the bottom, I have to do to the top. So then I'll write my new problem as 8/6 minus 1 times 3 is 3. 2 times 3 is 6. And then 8 minus 3 is 5/6. So I'm doing the same work to get both of my answers. It's the only difference is that I am cutting my box and then finding my new fractions just by counting the boxes and then subtracting. And this way I have to create my equivalent fraction and then I get to subtract. If you're really confused with this, I'm not expecting you right now to just kind of work through this video totally on your own. So if you need to, just keep playing this video and doing the examples along with me. That is totally fine. So let's go ahead and take a look at the next problem. So for this next problem, I have 1 1/5 minus 1/3. So remember, again, I am not drawing a model to show 1/3. I'm only drawing 2 different area models to show 1 and then 1/5. So I'll draw my box for 1 and then for 1/5. So this is going to show my 1 and this will show my 1/5. I will cut this vertically into 1/5. So do this along with me right now. If you want to try and pause this video and do it on your own, you can. If not, then you can totally just keep watching along with me. as long as you're still doing the work in your notebook or on your desk. So I'm going to shade in 1/5. So I cut it into 5 pieces because my denominator told me to. And then I have just one piece that's going to be shaded in. My whole needs to be completely shaded in like this. So completely shaded in the whole. All right, now what I need to do is I first need to cut both of my models into thirds. The reason why I'm cutting it into thirds is because I have 1/3 here. Remember, your second fraction, you always cut your models horizontally. So horizontally, I'll cut this into thirds. So I have one. Oh, that was the prettiest picture, but you get what I mean. And then I'll cut this into thirds as well. I'm going to make this a little bit nicer. There you go. So I cut that into thirds. So I have 1, 2, 3 pieces here, and then 1, 2, 3 pieces here. But my models still do not look exactly the same because I have a 5th right here. So I cut this model into 5ths, and then I cut it into thirds. So since this model was cut into thirds, I now need to cut it into 5ths. And I'll do that vertically. 1, 2, 3, 4. So now I have 2 models that look the same except for the amounts that are shaded in. And I need to write my new equivalent fraction for 1 1/5. So what does 1 1/5 look like now? So I'm going to count the total of shaded in boxes here, and then the total of shaded in boxes here, and that will make my new numerator for my equivalent fraction. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have 18 over, remember, it's just the total of boxes from this model. So if I have 5 and then 3, that is 15. So my new fraction is 18/15. So you'll know if you did this part correct if you get an improper fraction. So if you don't get an improper fraction for this part, where your numerator is bigger than your denominator, you may not have done something correctly. But if you get an improper fraction, you most likely did the right thing. So I have 18/15 minus 1/3. So I'm going to leave it like this, and then we'll come back to doing it numerically after I finish doing my problem here. So if I'm subtracting 1/3, what I want to remember is that I cut my model into thirds horizontally. So one of these chunks, basically, one of these third chunks is going to be the boxes that I cross off. So starting at the bottom, I'm going to cross off my thirds. And I need to remember or think about how many boxes did I just cut off. So I cut off like this third bar. So I had 18/15 minus 1, 2, 3, 4, 5 over 15. And remember, this is also an equivalent fraction for 1/3. So 1/3 and 5/15 are still the same fraction, it's just a different way of showing it. And now I need to do 18 minus 5, which is 13 over 15. And I can check to see if that is my final answer because I can check all the boxes that are left over. So I'm going to count all of these up. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 13 out of 15 left over. Now I'm going to come up here and I'm going to do 18/15 minus 1/3. So remember, I need to create an equivalent fraction. So I need to think about, well, 3 times what would equal 15? Well, 3 times 5 would equal 15. And whatever I do to the bottom, I have to do to the top. So I am going to then write my new equal sign, and I'll write my new problem. So I'll rewrite 18/15 minus 1 times 5 is 5. 3 times 5 is 15. And now I can subtract 18 minus 5 is 13 out of 15. All right, so this is the work that you should have on your desk so far to show both of these problems. We just have 2 more problems to go through, and then you guys will be free to move on to the problem set and homework set. Remember, if you have questions, please ask. But I would like you to keep working through this video, even if it's a little bit confusing or hard, that's okay. But you just need to keep trying at least and working through these models with me. So let's take a look at the next problem. This one, we're not going to have to cut up our model as much, so this might be a little bit easier for you. So for this model, I have 1.5 minus 2/3. So I need to first show off my first fraction as a model. So my first box will be for my 1 whole, so I'll show my 1 whole. And then the other part of this fraction, or my mixed number, is a half. So I cut this one in half vertically. And now I need to shade in my fraction. So I'm going to shade in my half right here, and then I'll shade in my whole right here. So now I am showing you 1.5 total. So imagine if I had 2 brownie trays and Miss Coast ate 1.5 of the brownie trays. That means I ate this whole brownie tray, and then I ate half of this brownie tray, and I only left a half left over. Now I need to show you what this would look like being cut into thirds. So just like how I would with the other model, maybe I would draw it, and then I would cut it horizontally so each of these match. So to do that, I'll cut this into thirds, like so, and then I'll cut this one into thirds. So you always look at the second fraction and think about how many pieces you need to cut it into horizontally. So I'll cut it into thirds horizontally. And now, since I cut this model in half, I also need to cut this model in half so that it still shows the same thing. Now, after I do that, I'm going to write my new equivalent fraction. So I have to first count all of the new shaded in pieces. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 over my total amount of boxes just in my first model. So I have 1, 2, 3, 4, 5, 6, 7, 9, 6. I have an improper fraction, so I know I probably did this correct. And these are both equivalent fractions of each other. So I have 9/6 minus, I'm going to be subtracting 2/3. And this is where it might get a little bit confusing, because what I'm going to need to do is, starting with my whole, I need to subtract 2/3. Now, if you think about it, you cut your model into thirds horizontally. So you cut off this into thirds, and you cut this into thirds. Since I have to subtract 2/3 right now, I'm going to subtract 1/3 and then 2/3. So if I were to think about a box that was cut into thirds horizontally, that would be 1/3 and then 2/3. And it's like I cut this one into 1/3 and then 2/3. So we're going to color in like that. And then I have to write my new subtraction problem. So I started with 9/6 minus 2/3, but 2/3 in this case would be 1, 2, 3, 4 minus 4 over 6, because I have 4 pieces that I had to cross out over a total of 6 pieces. 9 minus 4 is 5 over 6, so my final answer is 5/6. To show you this numerically, what I'll do is I have to multiply 2/3 to make it an equivalent fraction. So 3 times what would equal 6? Well, 3 times 2 would equal 6, so I'm going to multiply both my numerator and my denominator by 2. And I'll write what my new problem is supposed to look like. So I have 9/6 minus 2 times 2, which is 4. And 3 times 2, which is 6. So now I have the same problem I got right down here. And then I'm going to do 9 minus 4 is 5 over 6, which is 5, 6. Again, I know these problems are very difficult. There's a lot of weird and different steps that you may not be used to, but keep working along with me. And we're going to work on our very last problem, and then you're going to try the problem set on your own. If you need help, please ask for help. And then we'll also be practicing on Zern and Khan Academy for this. So you guys should be solid on this by the time you have to do your exit tickets. So our very last problem is 1 3/4 minus 4/5. Again, I only want to show a model for this first fraction. So start off by drawing 2 boxes. And my first box will be for my whole, and my second box will be for my 3/4. I'm going to show you this model cut into fourths. So this model's been cut into fourths. And since I have a 3 in my numerator, that means I need to shade in 3 of these pieces. So I have my model now cut into fourths, and I'm showing you what 3/4 would look like. And I also need to show what this model would look like shaded in. Now that I have both my models shaded in, I need to cut them into fifths. So to show you what that would look like, I have to horizontally cut each of my models into fifths. So I have this one cut into fifths, and now I need to cut my whole into fifths. Now I have both of them cut into fifths. But remember, I also cut this model into fourths, so I need to cut this model into fourths so that they both look the same. So I have all of that done, and I'm going to now write what my new equivalent fraction is. So remember, I have to count up all of the boxes that are shaded in. And I'm going to do a little bit of a trick so this goes a little bit faster because this is a lot of boxes to count. I'm going to count the amount that is shaded in going over and then down. So I have 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So 4 times 5 is 20. And then I have to add the amount over here. So I have 1, 2, 3, 1, 2, 3, 4, 5. So that would be 15 because 3 times 5 is 15. So 20 plus 15 is 35 over 20 because I only want to count the amount of pieces that are over here. So I have 35/20. Again, I know I'm correct because this is an improper fraction, and this would be an equivalent fraction to 1 3/4. And now I need to subtract 4/5. And in order to do this, I have to remember that I cut this model into fifths earlier on, and I need to basically cross out 4 of those fifths that I created. Remember, you always start with your whole. You never want to start with your fraction side, just because you're not going to be able to cut off as much as you're actually supposed to. So I always start out with my whole. So if I'm crossing out 4/5, I'm going to start from the bottom. So I'm going to cross off this fifth. So that's 1/5, 2/5, 3/5, and 4/5. So this was a fifth, this was a fifth, this was a fifth, and this was a fifth. So this, and this. So I crossed all those off, and then I'll be able to count what I have left over. So if I were to write a problem to show this, I used to have 35/20. Then I crossed out 1, 2, 3, 4, 1, 2, 3, 4, 16 boxes in total. So I crossed out 16, so that'll be my new numerator, over 20. Remember, you can't subtract unless this denominator is the same, so it should always be exactly whatever this denominator was. And now I have to do 35 minus 16. Now, I'm not always expecting you to do math right off the top of your head. It's fine if you need to do a standard algorithm and solve it like this. So I have to do 35 minus 16. So I will cross out that 5 because I can't do 5 minus 6. This becomes 15 because I borrowed from this 3. 15 minus 6 is 9, and 2 minus 1 is 1. So I will be left with 19/20. I can check if my answer is correct by counting up the boxes that are left over that are still shaded in. So I know I had 15 over here, so I had 15, 16, 17, 18, 19 over 20. Now to show it to you numerically, I have to create a common denominator between my 4/5 and my 35/20. So I have to think about 5 times what would equal 20. Well, I know I can multiply 5 times 4 to make it 20. And whenever I put these parentheses, that just means that I'm trying to multiply this fraction by this fraction. And whenever you multiply fractions, you just go straight across. It's actually pretty easy. And then whatever I do to the bottom, I always have to do to the top. So if I'm multiplying by 4 on the bottom, I have to multiply by 4 on the top. So when I go ahead and multiply this, I will create my new problem, which is 35/20 minus 4 times 4, which is 16, and 5 times 4, which is 20. So I have 35/16 or 35/20 minus 16/20. I remember that 35 minus 16 is 19, and I still will keep that same denominator of 20. And that would be my final answer for this problem. I know that doing the picture models can be a little bit confusing because there's so many boxes sometimes, but I would like you for this lesson at least to keep doing your area models, and then I would also like you to try and do the numerical way as well. It's going to take a lot of time, but I want you to kind of flip-flop between both of these and keep practicing that. I know this lesson was kind of a doozy, so take a little brain break if you need to, and then you're going to get started on your problem set. So give me a second, and I'll write it up on the board. All right, 5th grade. So for your problem set today, I'm only going to give you 4 problems, A through D, and then number 2. So you have a total of 5 problems for your problem set. Again, I'll always put the answers up on Google Classroom, and then you can check your answers once you're finished with the problem set. So again, just 1, A through D, and then word problem number 2. Yes, I would like you to try to do it numerically and with the picture models as well. Picture models you have to do. And then for homework tonight, you're going to be doing number 1, A through D, and number 2 as well. Please circle your homework right now and then put that into your backpack, and then you can get started on the problem set. If you need to do a small group with me, please make sure that you let me know, and we can go to the back table and work on a small group. Good luck on this, and have fun.